And hello everybody, here are some quick notes for defining the trigonometric ratios. So we're going to be looking at right triangles and discussing what the three different trig ratios are. There's going to be three. One of them is going to be what we call the sine ratio, and we often abbreviate it SIN, sine. The other one is going to be the complementary sine ratio, or cosine. So the CO, the co, stands for complementary, so cosine, and we abbreviate that COS. And the third one is going to be tangent, and we abbreviate that TAN. So those are going to be our three basic trigonometric ratios that we're going to look at on a right triangle. To kind of understand where the trig ratios are coming from and why they're so important, some of the keys here is that in a right triangle, for any particular acute angle, the ratios between the corresponding sides will be the same since the triangles are the same shape regardless of size. So what we're saying here is if we have two triangles that have the same angle but they're just different sizes, so let's say we had a smaller triangle, and we'll look at angle theta. So we'll give that a name. We often use theta to represent an unknown angle. So if we look at this right triangle and we label the sides, we'll call this side A, side B, and side C. And if we drew another triangle, let's say we increased it in size by maybe a scale factor of 2, doesn't really matter what the scale factor is, but let's say we made it the same shape but a different size. So we'll call this the larger triangle, which is 2 times bigger than everything. So the angle is going to stay the same. So if the theta was, for example, maybe 23 degrees, then this one is also going to be 23 degrees. If it started out as 37 degrees, then the angle in the bigger triangle is going to stay 37 degrees. It's basically the same triangle, just a larger version of itself. And if we label those sides, this side over here, what was side A is going to be 2 times A. It's going to be twice as big. Side C is going to be twice as big, so it's going to be 2 times whatever the original C was. And side B is going to be 2 times the original side B. So if we start to look at the ratios between the corresponding side lengths, we're going to notice that even though we change the size of the triangle, the ratio is not going to change. And this gives us a situation where it's going to be predictable. As long as we know the angle in a right triangle, we know what trig ratio it has to follow for that particular angle. And that's going to help us fill in missing sides and solve for missing sides when we're dealing with right triangles. So for example, the first ratio, let's say we look at angle theta. And let's look at angle theta in the smaller triangle. So if we're looking at 3 sides, we can kind of make 3 different combinations of ratios. Ratios are just fractions between the side lengths. So if we look at theta and we look across the triangle, we're going to call that the opposite sides because you're going to the other side of the triangle, so we're going to call that the opposite leg. So this will be opposite. So this is the opposite leg. And then if we look at the hypotenuse, and we compare those two numbers, then the ratio would be the length of A compared to the length of C. So this is going to be an A to C ratio. Notice if we do the same comparison in the bigger triangle, so if we go here and we look opposite, we get 2A. And if we look at the hypotenuse, then it's going to be 2C. But notice if we simplify this 2A to 2C ratio, then you're right back to the basic A to C ratio. So as long as you're working with the same angle and you're comparing the same sides, the ratios are going to stay the same, and that's kind of what trigonometry is all about, and why trigonometry works the way it does is because you essentially have the same triangle, just a smaller or bigger version of itself, so the ratios will be predictable for any one particular angle. And just to kind of see that, again, let's go ahead and do one that has some numbers in it. So we were looking at Pythagorean triples in one of our earlier lessons, so let's just maybe look at one of those. So if we had, for example, the 3, 4, 5 Pythagorean triple, you can kind of see it this way as well. So if you had a Pythagorean triple, and let's say this was my angle, whatever that is, this is 3, this is 4, this is 5. If I go make a bigger version of this Pythagorean triple, let's say we made it 3 times bigger, that means the side that was 3 will become 9. The side that was the 5 will become 15. And the side that was 4 will become 12 because everything is 3 times bigger. The angle theta will stay the same. So if this started out as a certain angle measure, then it's going to be the same angle measure since it's the same shape. But if we start to look at the basic trig ratios, again, if we compare sides, so if we made a comparison between the 3 and the 5, then that's going to get us a 3 to 5 ratio. If we made the same comparison in the bigger triangle, it's going to be a 9 to 15 ratio. But if you simplify the fraction, 9 over 15, that is going to be the same ratio as 3 to 5. So you have 3 times 3 makes the 9, 3 times 5 makes the 15. You have common factors, so you can cancel common factors. So essentially, after you're done simplifying that larger factor of 3 out, you end up with the same ratio. So that is why trigonometry works, because you're essentially dealing with similar triangles. Therefore, the ratios are going to be the same ratio, and this lets us solve for missing sides and solve for missing angles if we know what the ratio or the angle is always supposed to be for those particular angle measures. So let's go do the official notes for the note page. So here are your official notes. And let's just go ahead and fill in the blanks. So it says definition, a trigonometric ratio is the ratio of the lengths. So we're talking about lengths of those sides. Lengths of the two sides of a right triangle. So trig ratios, you're always going to be comparing the lengths of two sides of the triangle. And you can look at the triangle from two different vantage points. You can look at it from one of the acute angles, or you could look at it from the other acute angle. We don't look at it from the 90-degree angle, since all right triangles have a 90-degree angle in it. So we're going to be talking about the acute angles. And we're going to have the sine ratio off of angle A, cosine off of angle A, and tangent off of angle A. We'll go make a picture and define those in a second. And then we're going to go to the other side of the triangle, and we're going to do it using the other angle on the other side of the triangle, i.e. the complementary side of the triangle, and look at the trig ratios from the complementary side. So let's go ahead and hop over a page and draw a picture real quick that we can work with. So let's say this is our triangle. And it's a right triangle. We'll call angle A over here, and we'll put angle B over here, so this will be side C, and then we'll give it some names. Traditionally speaking, to label the sides and the angles of a triangle, The side opposite the angle, they have the same letter, just one's capital and one's lowercase. So if this is angle A, this is going to be lowercase side A. If this is angle B, this is going to be lowercase side B. And angle C, this is going to be lowercase side C. So if we look at the ratios, let's use angle A. So the side that is opposite of angle A, we call that opposite, or opposite leg. And then C is always the hypotenuse. And then B, we're not going to call B opposite because B is not across the triangle from angle A, it's actually right next to, and another word for right next to is adjacent, so we call that the adjacent leg. And then there's going to be three different comparisons we can make. We can make the sine comparison. So we'll say the sine ratio off of angle A is equal to, or it's defined as being opposite versus hypotenuse. So it's going to be the opposite leg versus hypotenuse. So we'll call that A to C. And sometimes just when people are first learning their trig ratios, they think of it as opposites and hypotenuse and adjacents. So you could think of that as opposite versus hypotenuse, so O versus H. If you look at your cosine ratio, off of angle A, cosine ratio is defined as being the adjacent leg to the hypotenuse, so that's going to be the adjacent leg to the hypotenuse, so that will be B to C. So side length B to side length C, and people often abbreviate that as adjacent to hypotenuse. And the other comparison we could make would be the tangent ratio off of angle A. So the tangent ratio is going to be opposite to adjacent. So this one compared to this one. So that would be comparing side A to side B. And when people are first learning these, they often think of that as the definition of the opposite leg to the adjacent leg. And an acronym that you've probably heard in some of your geometry classes to remember these three different comparisons is what they call SOHCAHTOA. So the first one, the S, sine, is defined as being opposite to hypotenuse. And then your cosine, so C for cosine is adjacent to hypotenuse. And then your T for the TOA is tangent, which is opposite to adjacent. So some teachers write it this way, SOHCAHTOA. If you read it all the way across, you might see it written as SOHCAHTOA. So an acronym to help you remember your three different trig ratios. So keeping that in mind, let's go ahead and put this right here into our notes. So working off of angle A, so let's just do these first three. So the sine of A is opposite to hypotenuse. In reference to the picture that we just made a second ago, then that would be the A to C. The cosine was adjacent to hypotenuse. And again, in reference to the picture that we just drew on the other page, that was the B to C. And then the tangent was opposite to adjacent. And in reference to the picture on the other page, that was, if I remember correct, that was the A to B. Opposite would be the A, and adjacent would have been the B. So there are your three trig ratios working off of side A on the triangle, so angle A on the triangle. You can also talk about your trig ratios from the complementary side of the triangle. So you could do the same thing, but looking at it from the vantage point of being at angle B. So if we go back and use the same SOHCAHTOA definition, so let's write that up here. So SOHCAHTOA So we'll use the same definitions: opposite to hypotenuse, adjacent to hypotenuse, and opposite to adjacent, but we'll look at it from side B. So if we go look at the picture that we had, so we're going to be over here at angle B, so we'll call that beta. So if we look at it from here, now our opposites and adjacents are going to switch. So for example, if I am standing at angle B, if I look opposite or across the triangle, your opposite is now going to be side B. So let's go ahead and redo these, but we'll redo them with angle B instead of angle A. So if I want to do the sine ratio from angle B, definition of sine ratio is still opposite to hypotenuse, but my opposite side is different. So now it's going to be side B compared to the hypotenuse, which is C. The hypotenuse will always be the hypotenuse. It's just the opposite and adjacent are going to switch. If you want to do the cosine ratio off of angle B, it's going to be adjacent to hypotenuse. So what's adjacent to angle B? Side A. So there's adjacent to hypotenuse. And if you want to do the tangent ratio from angle B, tangent is still opposite to adjacent, but what is opposite now? It's going to be side B compared to adjacent, which is side A. So there are your three trig comparisons working from angle B instead of working from angle A. So let's go put those definitions in our notes. So using SOHCAHTOA, so sine of angle B, we said that was going to work out to be B to C. Cosine, we said that was going to work out to be A to C. And tangent, we said that was going to work out to be B to A. So those would be your three trig ratios using the other side of the triangle. And one more quick thing for the notes, it will come up in some word problems, angle of elevation and angle of depression. So this angle of elevation is kind of what it sounds like, it's just the angle that you need to look up at. So for your angle of elevation, it's all in reference to your line of sight. So if we have a horizontal line of sight that kind of extends out forever, and let's say we're looking up at an object, let's say maybe it's a flagpole. So if we were looking straight out, this would be our horizontal line of sight. If we wanted to look up at the flagpole and see the top of the flagpole, we're going to need to change our angle that we look at. So that would be the angle of elevation. So we'll call it theta for whatever that angle is. So angle of elevation is what you're looking up at something off of your horizontal line of sight. And an angle of depression is kind of the same thing. It's going to be the angle that you need to look down at. So if you are looking down on something, so let's say we're on a cliff, and let's say we're up here standing on the cliff. This would be my horizontal line of sight if I look straight out. But let's say there was something down in the valley and you were looking at a car and you wanted to look down at it. Then this is going to be your angle of depression. And the reason these are going to be important is because if you're trying to measure distances looking up at something or looking down at something, you're essentially forming a right triangle. So if you brought a perpendicular line back up to your horizontal line of sight, you're going to be making a right triangle. And once we have a right triangle, we're going to be able to use the different tools in our toolbox for solving for missing sides and missing angles. Right now we can use special right triangles, we can use Pythagorean theorem, and eventually in the near future we're going to learn how to use those trig ratios. Since we know what the ratios between the sides are going to have to be, we'll be able to use those trig ratios to find missing sides and missing angles. And that is it for the official notes for just your definitions of sine, cosine, and tangent. So these are just the official mathematical definitions. Another video will show you how to apply these ratios so you can find missing sides of a triangle and find missing angles of a triangle. But the big idea here is knowing SOHCAHTOA and knowing how to identify which trig ratio you have to work with. You're going to need to know whether you're working with a sine comparison, a cosine comparison, or a tangent comparison before you can start applying these different ratios to help you solve triangles. So I hope you were able to follow that, and I hope you have a good day. We will talk to you later. Bye.